Good evening. Wow, it's great to see a nice crowd here tonight, especially on a not so promising night for observing afterwards, but thank you for coming up. My name is Drew Desker. I'm the director here at Kopernik, and every Friday night from March to mid-December we offer these programs on a wide range of topics. Just very quickly, who's here for the first time? A couple of people, all right. Who here are members? All right, fair amount of others. Well, especially the ones who raised their hands second, I'd like to point out that they have a very valuable piece of information. It's how valuable a Kopernik membership is. We offer three different levels of, actually four different levels of membership, but either for individual, for student, or senior, for family, or for a grandparent. And you know, that membership gets you into Kopernik on any Friday night and certain special events. But also what's great about it is we belong to what's called the ASTC, Association of Science and Technology Centers. And that our membership card gets you into 380 other locations. So if you like this kind of place, you know, a Kopernik membership is actually quite valuable. Actually, I took my daughter down to the Franklin Institute a few years ago, and had we paid street price for just myself and my daughter, it would have been more than the cost of a whole year's family membership. But you can get into Roberson for free. You could get into the Museum of Science and Technology up in Syracuse, or the Intrepid down in New York City. Corning Glass, yeah, the Corning Glass. They're also a member of the ASTC, so something worth considering. So Kopernik just finished its 50th anniversary of being a public observatory and an informal STEM education facility here in the Southern Tier, and we're just very blessed to have been able to be here for that amount of time. And and the programs that we offer have been really wide-ranging. Right now we're in the middle of doing a lot of school programs. Earlier this week we had some first graders and third graders in. Coming up this summer, we have a fairly extensive array of summer camps for students that are currently in first grade, maybe rising second graders up through high school. And these are week-long day camps on a wide range of topics. We also, as I said, like to do these Friday night programs, and I particularly enjoy them because it's an opportunity for me to learn a lot about the world, how the world and how the universe works. And as I said, it's not always about astronomy, and tonight's program is evidence of that. But what's neat about these Friday night programs is actually we actually, oh, wrong mouse, sorry. Why isn't it working? So back in 2020, we had to stop actually doing these programs because we couldn't, with COVID, we couldn't have people come in, you know, into a closed room. So we figured, okay, we'll just hold off for a couple of weeks for this COVID thing to blow over, and obviously that didn't play out exactly the way we would have hoped. So we said, look, why don't we start have our presenters zoom into our facility here? We'll just turn it back around and put it out on a YouTube channel. And so Kopernik has a YouTube channel with almost 14,000 subscribers. And every one of our Friday night programs, last week's was how to make a winning robot. It was actually a different, it was similar in nature, but on a much smaller scale. It was the Saints Robotics out of Seton Catholic Central. But then we had somebody out of the astronomy department at Cornell talk about quantum cosmos. We talked about AI previous to that, and the Fermi paradox before that. So, and you go down, you can actually see, you know, 5 years worth of programs on our YouTube channel. So, and even if you'd be able to see tonight's again, you know, later on this afternoon, later on this evening, if you want to go and review that. So, our Friday night programs have been very, very popular. We actually literally have people from around the world that will watch live. But also beyond our Friday night programs, when we do special astronomical events like meteor showers or eclipses, we've we've done that. And actually, Jenny Carty was running our live stream. We call her our live stream astronomer. Back in March, was up here for 5 hours and did a live stream of the lunar eclipse that happened in March, and she put together a really lovely 1 minute time lapse of the lunar eclipse. Over time, you can see that the exposure will change, because when it goes into full eclipse, right there, you're going to want to be able to start seeing the blood moon, only that red light content that is coming through our atmosphere that's lighting up the moon. The sad thing about this particular eclipse is it started at 2 in the morning. Of course, Jenny was here for the entire time. I saw that she checked out at 7 in the morning. I show up at 8 to start work. There have been times when we've done programs like this, and actually people in the chat will comment. And back a few years ago, we had a lunar eclipse that happened in a more reasonable time of night, and we had at one point over 25,000 people watching our live stream, and in the chat people were saying, we left NASA's live stream because we like yours better. So so kudos to Jenny for getting getting that kind of response out of people here. All right, so back to our website. So another thing that's coming up actually is our Rocket Fest, and this is a time when families will come together, or individuals will register for a rocket, one of those Estes rockets. They'll build it at home over a couple of week period of time. And then on June 7th, we've set up a number of launch windows for people to come up. You bring your rocket up, we'll check it out, make sure that it's ready to go. If there's any updates, that field modifications, as we like to say, we make sure that happens. Then we'll put the engine in, you go outside, you hit the button that launches the rocket 500 or 1,000 feet into the air. So if that has some interest for you, go to our website, you can register. There's still a couple of launch windows are already closed, but we still have more than enough time to take more rockets. Last year we launched about 113 rockets over the afternoon, so that was a lot of fun. So again, back to Friday nights. Again, this is really an opportunity for us to learn about how things work, and I like to say that I really wish I could live another 50 years or so, because I'd like to see. I remember watching Neil Armstrong walk on the moon. And how has technology progressed just in my lifetime? As I like to say, especially for even the young people here, it's like when I was your age, I used to have to walk to the TV to change the channel. Yeah, now you can watch it on your phone. So anyway, we're very fortunate to have a very active robotics group. The Southern Tier Robotics has gone through some name changes, but has been around for how many years?
Since
2007. So closing in on 20 years. And they've been very gracious to every year to bring their robot up. And as you can see, it's a non-trivial effort to bring it up here. But I think it's a great opportunity for them to show off the hard work that they do. And also it's a great opportunity for you all to learn of what great stuff is going on here in the Southern Tier. So at this point, I'm going to pass the microphone off to Drew Williams, who was one of these engineers a while back, and let me change over the get the.
You move the laptop. Oh.
Yeah, no, that's all right. There we go. All right, in a moment. Should be there. There you go. All right.
Hello all, my name is Drew Williams. I'm the head mentor of Southern Tier Robotics, otherwise known as Vestal High School Robotics Club, or previously Tigertronics if you've been around a while. And I'm here to tell you guys a little bit about what we do as a team, and then I'll hand it off to the students to explain in more detail what our robot does. So we're part of an organization called FIRST, which stands for the Inspiration and Recognition of Science and Technology, which is kind of a long name, but really the goal of the organization is to get kids of all ages involved in STEM and hopefully get them to pursue a career in STEM. So our specific team is part of the FIRST Robotics competition, which is the high school level team or high school level competition. There's a bunch of different levels, so they also have elementary school level teams for which is FLL, and then middle school, which is FTC. But yeah, we're FRC, so the highest level. Like I said before, we were previously called Tigertronics and moved to Vestal in 2021, and that's when I became head mentor. I was a student on the team from 2013 to 2016 and helped out in college a little bit. So this year we had around 20 active students, and I think around 15 to 16 went to each competition. So that's a team picture of almost everyone that's on the team. This year some mentors are in there as well. Yeah, and our robot is in the middle. So there's two kinds of members on our team, students and mentors. Obviously students are students that are high school aged, and they work on building skills in STEM as well as learning about different engineering skills and stuff like that. They work on building the robot, and then there's also mentors. So mentors are they basically help the students learn and grow in whatever they're interested in while on the team. So I help out a lot with the software side of things. We have mentors that also do that help out with machining or CAD or general robot assembly and other stuff. So a lot of the mentors that we have are alumni of different teams from around the area and also engineers in their day job. None of us are actually teachers, so it's a good experience for students to learn real world engineering skills that they wouldn't really get in a class or anywhere else. So here's a little bit more about our timeline for the season. So from the beginning of the school year to Christmas break, we work on training new members, and we do that by attending off-season competitions, building robots, learning CAD, using the machines, and then January through April is what we call our competition season or build season, and that's where the game that we have to build a robot for is revealed. So I think from when the game was revealed to our first competition was around eight or so weeks. So we have to go from nothing to that robot in that time, which is very intense. So that's why we try and prioritize training in the off season. And then right now from April to June or to the end of the school year, we do a lot of outreach events, fundraising, some training, and then general cleanup stuff to try and get ready for next year. So this year we went to 2 official competitions, one in the Hudson Valley area or like Rockland Community College, and then also one in Albany, which was the Tech Valley Regional. And we're also attending a couple off-season events, one in Worcester, Massachusetts in June, and a couple in the fall. So we're based out of Vestal High School in the wood shop and like computer lab area. So we have lots of machines and resources available to us. We have like computers that we can do CAD on, a lot of metalworking tools like a CNC mill, lathe router, and then also wood shop stuff. So before I pass it off to the students, I'll play a quick video describing what the game was this year. And it'll be confusing at first, I'm not going to lie, but after you see the robot demo and stuff, you'll get a better understanding of what we actually had to do. Yeah.
Welcome to the 2025 First Robotics Competition game, Reefscape, presented by Haas. 2 alliances of 3 teams each compete to earn points by harvesting algae, seeding coral on their reef, and returning to their barge to ascend to the ocean's surface. Alliances earn additional rewards for meeting specific scoring thresholds and for cooperating with their opponents. Prior to the start of the match, teams can choose to hang a shallow cage or a deep cage on their barge. Robots start each match at their starting line and may be preloaded with 1 coral. During the first 15 seconds of the match, robots are autonomous and can be programmed to leave the starting line, remove algae from their reef, and place coral on their reef. If all enabled robots on an alliance leave the starting line and score at least 1 coral in auto, the alliance earns the auto ranking point. During the following 2 minutes and 15 seconds of the match, drivers control their robot. Robots can place algae in their net and collect coral from human players at their coral station to place on their reef. Coral placed higher on the reef are worth more points. If an alliance can score enough coral on all 4 levels, they will earn an additional ranking point. Robots can also deliver algae to their processor. Once processed, the algae can be taken by the opposing human player and scored into the net. When 2 algae are delivered to each processor, both alliances earn a co-op point. The co-op point reduces the number of coral needed on the reef to earn the ranking point and influences a team's rank in the tournament. As time runs out, robots race back to their barge to hang on their cage and ascend to the ocean surface. Points are awarded to robots that can hang on a shallow cage, and even more points are awarded to robots that can hang on a deep cage. An alliance that scores enough barge points will earn the barge ranking point. The alliance that earns the most points overall wins the match.
So this is the robot that we made for this season. We named it Rattlesnake after a glitch that would occasionally happen with the elevator. So our season starts on the first weekend of January when we all are given the game for that season. We this year met at Binghamton University to plan and watch the live stream. So once we watch the live stream and we get a good idea of how the game is going to work that year, we all get together and we discuss strategies and approaches to the game. So at our next meeting, we would be back in the high school and we start prototyping systems for our robot. So here in this image, we have a very early version of our funnel, which is right here. And then the prototyping stage, it happens over a long period of time as we refine our subsystems for the robot. So here is a later version of the funnel and is far closer to what is currently on the robot. Once we're done with our prototyping, we get together and we discuss what designs worked, what didn't, and what could be improved. And this is where we choose exactly how we want our robot to be during the season. And then once we have rough ideas of the robot, we get to work making models of the parts, like individual parts for it, in a software called Onshape that we use on the school computers. And those 3D models are sent to our manufacturing team, who uses the CNC machines that we have in our workshop, like the mill and router in those two pictures there, to make the actual parts that we design. And then once everything is manufactured, it's all hands on deck to assemble the robot as fast as possible so that we can get to testing it to make sure that it works. And then we also have a team of students who does electrical, so they wire everything and make sure that our cameras and our motors and computer is working properly. And once all the subsystems are together, we put it on the robot to put the whole thing together. And then once everything's together, we do a quick check over everything, make sure that nothing is forgotten or put on any finishing touches to make the robot functional. And then it's ready for testing. At this stage, we make sure, once again, that it meets all the requirements and is within the rules of the game. And then we start testing. We start programming the robot and making sure that it can do all the things we want it to do. So we set up a fake field in our classroom to fine-tune all of the systems that we made. So in this video, we are putting a coral on the top level of the reef.
No longer just a robot.
And then we take an algae or the big kickball, and we put it in a spot that would have been on the side of the field that we designated for that game piece. And then after roughly 6 weeks of building the robot, we go to our first competition. And the one shown in this image here is in Albany. And at the competitions, teams come from all over the world to compete. And you get to talk with other teams about how they designed their robot, what they did that was different from yours. And you get to see, like, oh, we could have done that, or I'm glad that we did this because that doesn't look very good. So, and then a big part of the competition is our pit crew, who is a small group of students who after every match, they make sure that the robot is still working or fix anything that broke during the match. And they'll make sure that it's ready for the next match when the time comes for it. And then we have the drivers who drive the robot, and a human player who stands usually on the side of the field to give pieces to the robot or manipulate the field in some way. And then there's a group of students in the stands who scouts is what we call it, and they watch the matches closely to see what teams do and how well they perform compared to ours. So the first 15 seconds of each match are autonomous, and then the 2 minutes and 15 seconds are controlled by the driver and the operator. So the field is quite large, and here we have the reef, and then the barge here, which is a big net that all the kickballs go into, and then here are the cages that you have to climb on at the end of the match for extra points.
The lines, starting in 3, 2, 1, go!
So this is one of our matches that we
match
won.
68. Autonomous
You can
control.
see
First to
us
strike
right
is
here
1796. The
in the
green
corner.
machine on the far blue side of the field. Robo Tigers finished their first day of competition undefeated with a
So what we're
staggering
doing right
ranking
now
score
is
of
going back and forth
5.86,
between the
meaning
player
anything
station,
other than a
who's
perfect
giving us
6
game
ranking
pieces,
score
and the reef
in any match will
is
lower that
scoring
ranking
those game
score for the
pieces for
Robo
points.
Tigers. Incredible stuff coming out of the teams from Queens. 52-9, Blue Alliance takes the advantage here in the opening period of play. 15-18 trying to close the gap here early with that score in the barge. The algae, we've seen 15-18 run this strategy all weekend long, and already back at the barge here, Raider Robotics with another 4-pointer up high for the Red Alliance. Blue Alliance has secured 1 out of the 4 levels they need for the ranking point. We'll see if they continue going up high. Robo Tigers looks like they are switching to level 3, which makes sense for the ranking point. Southern Tier Robotics will follow suit for blue. 2 red machines focused on Coral deep in their zone. The Hurricanes looking up high, and their alliance partners Astro with the 5-point score as well. Hurricanes trying to find which branch they want to score on as their alliance partners move into position. Hurricanes sliding that Coral out, but unfortunately denied by the Reef branch, and they head back to their human player to recollect. Red Alliance is closing the gap, but Blue Alliance still has a strong lead here, 110-70. Blue Alliance completing the ranking point here in the first minute of play. 1 minute left to go. Co-op is engaged, so only 3 levels needed here. Red Alliance needing 2 more for the same feat. 15-18 back at the barge for another 4-point score. 17-96, and their alliance partners, Southern Tier, working up high once again. Now with the ranking point complete, they can focus on match points, and that's going to be filling up the top level of the Reef here first. And it looks like with that delivery from the Robo Tigers, 1 position remains for the Blue Alliance on level 4. 25 seconds remain in the match. Blue with a strong lead going into our final period of play, 127-96. Barge filling up here on the red side of the field, 15-18, continuing to pop those
seconds
in.
of the match,
Southern Tier is the
it's
first
referred
one
to
get
as
hooked,
end
but
game.
they are still on the
That's
ground.
when
Robo
most
Tigers
robots attempt to
airborne with
climb
7
on their
seconds left
cages
to go.
or park in
Red
an area
Alliance
designated on the
looking
field
for
to
the
get a little bit of
climbs
extra
with
points.
3 seconds in play, and time expires in match 68. The green machine from...
So we won this match. And then during our off season, we do events with the community. So in this picture here, we had some elementary kids who were on the Lego League team come see our robot. And because they would eventually, if they come to the high school, they can join our team. So we demonstrated the robot to them, and we showed them the systems of the robot and explained everything to them and how it would compare to their robot. And then the Lego League also had an exposition at Broome Community College. So we brought our robot there to show some of the other teams in the area our robot and what they would be getting into in the future.
Yeah, so Mason did a good job of explaining the game and this year's robot and everything. So anyone that's from grades 9 to 12 that's in the Vestal District is free to join. We're currently working on trying to expand it to other districts in the future. And we're also looking for new mentors that are interested and willing to help teach the students and also learn about FIRST. And while a lot of our mentors are engineers, really any skills are helpful. And yeah, just getting real-world engineering experience to the kids is what is good. If you want to contact us, feel free to visit our team website. And my email's also up there. Drew, and then either me or Art will get back to you. I think we also have business cards we can give out to later. And then just a quick shout out to our sponsors, some of our sponsors from this year. So yeah, we have a bunch of sponsors from national and as well as some local companies. And there's more on our website. So that's about it. I think we're going to do a quick robot demonstration now, and then we'll go into questions or and then also after the demo, feel free to like walk up and take a closer look at the robot. Yeah. I'll go back to the contact slide. So while the robot's turning on and getting set up to go, I think one of the things that everyone on the team works. So we're at the we're at the high school during the build season from like 5 p.m. to 8 p.m. Monday, Wednesday, Fridays, and then also Saturdays from like 8 a.m. to 1 p.m. So it's a lot of work, hard work, especially during the build season, and all the kids should be like really proud of how well we did this year. So this year was probably our best that we've ever done. I think as a team, almost ever. And I believe I think we're like out of like the 300 teams in New York State, I believe currently we're like the top 10%. So we did pretty well this year. And next year we're always looking to improve and try and win one of the competitions. So we're going to enable the robot now. Yeah, should be good. Oh. There you go. So the robot gets pretty beat up over the competition season, so yeah, it can get pretty rough and hard to drive sometimes. Also, our real driver isn't here today, so I'm gonna be driving. I'm not like the best driver, so yeah, I'll be careful.
Do we need to get insurance releases from everybody?
Yeah. So we'll demo scoring a coral. And actually, normally the driver has a button that they can press that will automatically align using a vision system on board to the closest reef segment. But because the field isn't set up here like normal, we can't really do that. So I'll have to manually align everything. Are we good? I think so. Yeah, and then you want to try and grab the algae. Yeah, you can set it down. Nice, and spit it out. Oh, it's fine. Yeah. So that's kind of a general. So the robot can go a lot faster. Like the field itself is like 50 feet wide or 50 feet long by 15 feet wide, and the robot itself can go like 15 feet per second. So it goes really fast. Obviously, I will drive it a lot slower here, but yeah. So we'll do a little spin move. Yeah, it's pretty cool. I mean, I guess we can. Does anyone have any questions to start about the robot or the team or anything in general?
When we do have questions, we're going to just bring this
pass the
microphone
mic.
over so
Yeah.
that the people on the live stream can hear you. So just give me a second here.
I just wondered what happens with the ones that, with the previous year, do they get stored somewhere or do you take them apart and use the pieces again?
Yeah,
what
so
do you do with the ones that are no longer?
yeah, so like last year's game was completely different. So what we end up doing is the parts we can reuse, like the motors and yeah, like the motors and the wheels and stuff that don't really wear down, we can reuse, but the rest of it just ends up as scrap, or we use it for like prototyping the next year. So we go through a bunch of metal each year and polycarbonate sheets and stuff, but yeah, we can reuse a fair amount of stuff.
It's like losing a friend. It's like Wall-E that,
Yeah.
that
Well,
disappears.
I know some teams, yeah, some teams can afford to keep their robots together. We're not one of those teams, but yeah. Some teams also keep like just the shell. But any other questions? Feel free to take a closer look too now if you want.
Well, I guess one thing I'll just comment on that. I mean, I've seen you bring your robots up here now for the better part of close to 10 years now, but I don't think I've ever seen them work that fast. They seems like they've really improved the the motion mechanism. I also noticed that this year's competition seems like there was little to no interaction. Like the Blue Alliance was on one side of the field and the Red
Yeah.
Alliance was on another, and it didn't seem like the two interacted?
Yeah, so that's a good question. So part of the they're kind of interlinked actually. So the because there wasn't a lot of interaction, a lot of the robot performance comes from your individual robot and not how you work as a team, which is kind of specific to this year. Whereas last year, the robots could work together a lot more by like passing notes to each other and stuff like that. But this year, your robot itself has to be very efficient at what it does to do well. So we put a lot of emphasis on, especially this year, about automating certain tasks. So like the automatically aligning to the closest segment, and then also our robot will detect what game piece it has and move to a certain, like it has to be able to move to certain safe end effector positions based on that. So that along with just there's a lot more powerful motors that are allowed back compared to like back 10 years ago. So like they have brushless motors now that you can use compared to old brushed motors. So it's a bunch of different things.
I'm also noticing a QR code on the
Yeah.
on the receiving. Could you talk about that a bit?
Yeah, so that's an April tag. There was a bunch all over the field this year, and that's what the camera recognizes to tell where it is on the field. So actually I can pull up a video of what the robot sees, if I can.
All right.
Oh.
Let me see.
Oops.
Should be there. Reboot.
Okay.
The video at least. Sorry.
While they're doing that, one thing I want to invite everybody is we're still doing sessions, club sessions at the high school, and if anybody's interested in coming down and just take a look at what we do and the equipment that we have, talk to me or Drew, my business cards also with contact information. So we'd love to have you come down and see what we do.
Yeah. Oh.
While we're waiting, could you explain what some of the other years' tasks were? It's obviously different every year, but what other sort of tasks in other years did people have to do? I mean, this is obviously under the sea and coral and all, but what are the other
Let's see.
tasks in other past years?
Yeah, so last year the main task was to basically put there was these foam rings that your robot had to shoot into a goal that was in the air, and there was like there's a bunch of different like themes, I guess you could say. So last year was kind of like music themed. It was called Crescendo, and the year before that was called Charged Up, and you had to pick up like rubber traffic cones and put them on different parts of the field. It was kind of they're hard to explain without seeing the video, is what I'm trying to say, but yeah, so the sorry. Anyway, yeah. So back to what I was saying before with the April tags. So our robot has 2 cameras on the front, and basically that can tell where the robot is once it sees the tag. So that'll we basically do a bunch of math on the computer to figure out where the robot is relative to the tag, and then we can add a bunch of automated things like if we're near this tag and we press the score button, automatically move the robot to that location. And we can be pretty far away. Like if it saw the tag right here and we press the auto align button, it'll smoothly move all the way here, even if like it's not aligned rotationally, and drive up and score. Yeah, so question.
Your mentioned this year that there wasn't much cooperation between the teams. Do you do anything to discourage your competitors, or do you just, you're so busy trying to do what you've got to do, you don't have time for that?
So there was as the drive coach of the team, my job is to talk with our partners during each match, before each match, and figure out what our strategy should be. So, oh, there we go. So, for example, our robot was good at scoring, well, it was best at scoring on the L2 and L3 levels of the reef. So we would talk with our partners and say, hey, you guys are good at L4, you do that, and we'll fill in the bottom levels. And your partners are random every match. So there's a lot that you have to strategize before the matches, and then also you have to think about what the opposing alliance can do as well. Let's see. Okay. Yeah, so each match is completely random with who you're paired up with until the playoffs. And then you get to choose your partners. So here's kind of like what the robot sees. This is from last year's game, but you can see the robot squares on that little field overlays, all of the camera data and where the robot thinks it is compared to where it actually is. And so we do a bunch of data logging to be able to replay that afterwards and like diagnose issues if it comes up. Yeah, so any other questions? Okay.
Or grabbing a hold of the
Yeah.
what that was called?
So at our first competition, we didn't have our climber mechanism on because we just didn't have the time for it, and that was our lower on our priority list. So when at the first competition, we just said, you guys do whatever, we'll just keep cycling coral and stay out of your way, and then park at the last second. And then at our second competition, we tried to climb, but so we have like a locking mechanism that would lock the climber arm at the end of the match. It didn't end up working at competition, so all of our climbs were like off the ground, but then when the robot gets disabled, it would like slowly fall. So I don't think any of our climbs unfortunately counted, but it's a lesson learned, you know. Yeah, so that competition we said, I think it depended on who we were with, but I think we mostly tried to climb because we would end up parked anyway. I believe I saw a couple more questions. Yeah.
So you said what the other competitions were, but what were the other robots? Or was it like the same? Or?
Yeah, so the base of the robot that like moves it around on the ground usually stays similar year to year. So like, so that in the left side is our robot, and it was a lot smaller, but it shot those orange rings. It picked them up off the ground and shot them into the goal. So I think this was near Albany as well, and then we also had to climb a chain at the end of the match. So we'd drive up and then score or climb at the end. Yeah.
It seems that almost every competition there is a you have to lift the robot up. Is that sort of pretty consistent or not always?
It's kind of I would say it's like generally most of the time there's some kind of climbing thing, but in 2023 there wasn't. You actually had to balance on a like seesaw kind of thing with your teammates at the end that you could just drive up that. But yeah, there usually is some climbing just because it's exciting for people to watch, and when the robots fall.
Oh, got another question over here. Hold on.
You mentioned that the first 20 or so seconds was autonomous. Could you talk a little bit more about what your plans were for that and how you did it?
So all of our robots, or I believe like almost every year since I was a student, the first 20 seconds is auto. So we usually have a couple pre-planned like modes that we select from, but depending on who we're with. So like if a team that has a really good autonomous mode that starts on the left, and they only have that, we have one that like starts on the right side or the middle. So we're able to work with our partners. But we usually try and usually the points work out to where the autonomous is worth more points than the same thing in teleop. So being able to maximize your auto points is really good. So by the end of the season, we had an auto that could score 2 coral on L4 in auto, and sometimes it would, if depending on the timing, it would grab the algae off as well. And so what we do for that is we have a program where we can draw the robot where it wants to go, or where we need it to go, and then we have a bunch of almost like actions we say to do along the path. So let's say like we're halfway through, then we want to raise the elevator, stuff like that. So we have almost like a little program that lets us quickly make autonomous routines, we call them.
Routines, right? So you're not.
Yeah.
It's not actively searching for a target.
So, yeah, some teams did do that this year. They had a camera on their robot so some teams were able to pick up these coral pieces off the ground, and they had a camera that could detect where the coral was, so it would automatically drive to it. So there are teams doing stuff like that, but with our robot design this year, only designed to load from the station, we didn't really need anything more advanced. The most, so I guess one thing that it does autonomously is it detects if at the end of the path we'll do like a final alignment, which will drive it to use the same code that aligns it to the reef. Yeah.
Thanks. Like Drew said, the motion you guys had that was pretty tight. Good job.
Thank you.
Got another question here back.
Does it have different speeds, or can it only go fast? Could you do this again, but in slow motion, so we could actually watch what is happening? Or is it a matter you press the button less and it's slower, or is it always either yes or no?
So for the elevator mechanism, not really. We can move the elevator up and hold it there though if you want. Yeah, we can like run it up and down a couple times. No, I didn't. So that's kind of like the default position, and you can move to the different levels. Honestly, there were teams faster than us too. Like, some of the robots could move up from bottom to top in like half a second or something.
Extraordinary.
Thank you.
Any other questions? Oh, all right, sure. Give me another second here.
So for requirements, do you guys get a certain number of hours you're allowed to work on a design before you can implement, or is there a certain maximum amount of time that you can spend developing your robot before you have to go to your first competition?
No.
You've got like a calendar set, but I didn't know if you had hours.
Yeah, so the build season process is more like the game gets released, all the teams across the world get it at the same time, and you have until your first competition to get your robot done. So it has to be competition legal by the time you get inspected. There's no rules about hours or anything like that. So, yeah, there's there's no rules about like where you can like a lot of the team members work on CAD stuff or programming stuff outside of meetings as well, just with the amount of work that has to be done in the time frame. So it is a lot of work, but yeah.
I recall in past years they used to have a certain period of time before the beginning of the competition that you would then have
Bag
to
it up.
bag. You'd have
Yeah.
to bag it, and you couldn't touch it until
Yeah.
you got to the competition. Is that still the case?
Not anymore. So they got rid of that for a couple of reasons. Mostly because you could get around the rules by you had a weight allowance that you could have outside the bag and inside the bag, and it kind of just gave an advantage to what ended up was supposed to be to make the playing field more level between the high resource teams and the low resource teams. Actually did the opposite, where the low resource teams that couldn't get a robot done in time ended up going to competition with basically not a robot against teams that had the resources to build a full robot and basically build a second robot after they bagged up their competition one, worked on that, and then went to competition. So they ended up getting rid of it.
Well, you talk about resources. Are you at liberty to say how much that robot cost?
Oh yeah. So I believe probably, if I had to guess, maybe like $7,000, $6,000. That's for all the motors, all the batteries, all the metal, all the wheels, all that stuff.
And then your fundraising also covers the cost of
travel, registration costs. Yeah. So our annual budget is probably, ideally it's like $50K a year, so we do a lot of fundraising. Most of it is honestly travel and registration. It costs $6,000 just to register for the first competition, and then $3,000 for every extra one you want to go to. And then paying for the busing and all that extra stuff is expensive. Yeah.
Right. I'm trying to think. I don't know
Lots
if
of
there's
credit card rewards though.
If there are
when
any
I pay for the hotels.
Comment or any questions from the chat. Although our friend Lindsay from Adelaide, Australia, is watching this morning. Wait, everyone say hello to Lindsay. Lindsay. There we go. Good to see you. Good day. Exactly. All right. Oh, got another question back here. Give me a second.
How long before the competition do you know what you have to have the robots do?
So the game gets revealed January 6th, first Saturday in January usually, and then depending on what competition you decide to go to, ours was considered quote week 2 of the competition season, so we have 8 weeks. But there's other teams that go to a week 1 competition, so they'd have one less week.
That's pretty quick.
Yeah, that's why we do so much training in the off season to get the kids up to speed, so we can work quickly in the build season.
Oh, got another question over here.
Do you have any kind of power restrictions with the batteries, or
yeah.
are you restricted to using only 24 volts, or can you go?
So, there's a SLA battery, if you're familiar with the battery. It's like a motorcycle battery basically. It's 12 volts, and everyone has to use the same voltage and amp hour and form factor battery. And there's a limited set of motors and what are called power distribution hubs, which basically take your battery power and distribute it to different parts of the robot. So everyone's limited to the same main computer, the same battery, and the same set of motors.
All right. Well, in the absence of any other questions, and we can certainly take some more afterwards. unless there's any other demo, I want to thank you, Drew and Art. And actually, could you introduce
Yeah.
your team members?
Yep. So this is Gershon. He's the operator. So he controls like everything that's not driving the robot. And he also helped out with CAD this year. And then Mason, he does a lot of the CAD and assembly of the robot. Milo, he does a lot of CAD and also assembly of the robot. Yeah.
And so these are all high school students from
Yep.
like 9th grade through 12th.
Yep.
Right. Excellent. Well, thank you once again. It was great to have you.
Thank you.
And we'll make sure to book you for next year as well. I look forward to that. And as always, we always have a rule here that you're not supposed to leave Kopernik until you look through a telescope. And tonight's not really going to be your night. But two things. One is if you paid to get in, we will give you a card to come back for free on another night. But otherwise, we'll also, for those that have maybe not seen our telescopes, we'll give you a tour of our telescopes. It's about 9 o'clock now, Eastern Time. At 9:10, well, meet me out in the lobby, and we'll take you through and give you a tour of our scopes. So thanks again. Yep. Thank you. Oh, also.